So today we are moving on to moderated mediation, or better known as conditional indirect effects. So we'll talk about conceptualizing conditional indirect effects, and then model specification, meaning that moderation can be at the A, the B, the A and the B path. So there's various ways that you can specify a moderated mediation model. We'll go through significance testing, which parallels the range of options we have for mediation. And then I'll actually also just do some odds and ends at the end, which is power for mediation and just some extensions and thinking about other analytic approaches and thinking about causal inference and that area of the literature. So, and then next week we're going to talk about GEE. So, how's it been going? Who has done some mediation in the past week? Tested some mediation models? Made grand discoveries? No? No shame. All right, well, it's there, I'm here, so definitely keep me posted as you move along. I'd be interested to hear, what kind of stuff that you guys come up with in terms of running through these different models. Who has tested moderated mediation before? 1, 2, 3. Okay. And what about mediated moderation? What about moderated mediation? That's John Kelly's joke. I'll try and I won't pretend it's mine. But yeah, so we'll talk about the differences between mediation and moderation and or mediated moderation, moderated mediation, how there really isn't a difference, and kind of thinking about the best ways to conceptualize these models. In terms of a review of last week, we talked about mediation as a type of 3-variable relationship that specifies a causal path from X to Y through M. Because this is one of many 3-variable relationships that can arise in regression analysis, it's really important that we have sort of careful measurement, careful theory, because this is really just about shared variance, right? We talked about extensions to the Barron and Kenny model, and that incorporate a series of regressions and calculation of the product of the A and B path coefficients, rather than meeting the incremental criteria that you would meet in a Barron and Kenny approach, which so more of that sort of the sort of conclusions that you reach based on the series of models versus testing the significance of an A-B path coefficient. Logical criteria is a good way to describe Barron and Kenny. Total, direct, and indirect effects are a useful framework for conceptualization and calculation of mediated effects, and we went through the output and looked at how you can pull the different coefficient values and crunch the numbers and how they all kind of relate to each other. Significance testing for mediated effects, there's a range of options. The range of options is the same for moderated mediation or conditional indirect effects. So there's the Sobel normal theory z-test. There's the Mac z-test, which is the McKinnon z-test, so the sort of asymmetrical distribution for looking up the significance of a particular AB coefficient value, as well as sample-based bootstrapping methods for constructing confidence intervals for the indirect effect. And single, multiple, and sequential mediations are options. We did a single and a sequential mediation model last week, and we're actually going to extend that this week. So here's our beginning model, the X to Y total effect. Here's our mediation model, which is the X to M A path, the M to Y B path, the product of those coefficients, the total effect minus the product of those coefficients is going to give you C prime here, which is the direct effect. So, conditional indirect effects. Conditional indirect effects broadly encompasses a range of greater than 3 variable relationships. So this term was coined by Preacher, Rucker, and Hayes as a way to kind of address the issues in the literature in terms of, okay, so Barron and Kenny and probably maybe Judd, Muller and Judd were sort of the first to start talking about moderated mediation, and then other folks came in and talked about mediated moderation, and things started getting a little confused. And then, so Preacher, Rucker, and Hayes wrote a paper that kind of tried to pull it all together and really clearly define, what these things are and what the different scenarios are for testing these types of models. And that broadly speaking, these are conditional indirect effects, right? Indirect effects that are conditional upon some level of a fourth variable. And there can be more than one conditional indirect effect. So there's many scenarios for this type of model, but generally moderation can occur at the A and or the B paths of a mediation model. And this paper describes 5 scenarios. So what I put in the folder for today is this paper, which is really what these slides are based on. When moderation is mediated and mediated is moderated. So the sort of the earlier paper that talks about mediated moderation versus moderated mediation. So that's in there as well. And then I think there's a power for mediation paper as well as a SAS macro, the description of a SAS macro for power for mediation. We'll talk about that later, but there's not a lot of great options for power for mediation. I actually tend to use the McKinnon tables and do quite well with them in terms of reviewer responses and so forth, but we'll get to that. So here's one model, one example. This would be an example of 2 different moderators, one moderator at the A path, which is W, and one moderator at the B path, which is Z. So in terms of the macro, there's ModMed, which is the predecessor to Process, which kind of pulls it all together. So ModMed is also on the Hayes website. They both provide the results for the mediator variable and dependent variable equations. They provide the confidence intervals for the indirect effects at levels of the moderator, and the default is plus or minus 1 standard deviation from the mean. And then they also provide a Johnson and Neiman type technique for looking at which values of the moderator that the indirect effect becomes significant, right? So we talked about that during the moderation week, where we have this sort of continuous scale of, okay, the indirect, in this case, the indirect effect is only significant at low levels of the moderator and high levels of moderator, or some variation, only low, only high, etc. Does that make sense? You guys remember the Johnson and Neiman? Okay. So here's another example of a scenario. This would be where you would have the same moderator at the A and B paths. Okay, so what is mediated moderation? The purpose of mediated moderation is really to examine how a moderated effect occurs. Right? So this is the same logic as simple mediation, except that the independent variable would be the XW term, the W being the moderator. The intent here, I think the subtle difference between mediated moderation and moderated mediation is really around the sort of conceptualization and the intent. So with mediated moderation, you're really just well, I won't say just, but you're really looking to explain the nature of a moderated effect, right? So you found a significant interaction term in your model, and you're now saying, how does this occur? So in that sense, mediated effects at levels of W might not necessarily even be probed, although chances are they will. You have to covary X and W as would be typical in any moderation model, so the testing is the same. In terms of the equations, this is really testing moderation at the A and the C paths. Okay? But what you're asking here is how the XW effect occurs, so how the moderated effect occurs instead of asking for whom or under what conditions the mediated effect holds. Make sense? Mathematically, they're the same. I don't know. I guess I didn't get any hands for mediated moderation. It's very unpopular. Okay, so moderated mediation. Examine whether the mediated effect remains constant across different groups. So that's the purpose. With sufficient, just to think about it conceptually in terms of other methods, if you had a sufficient sample size and a categorical W, which you can make any W categorical, right, if you just create groups, you could feasibly just conduct your mediation analyses within groups, right? This is basically the same thing conceptually that we're trying to do. If you were working with an SEM framework, you might constrain your mediation paths to be equal across groups. So you would conduct the mediation between two groups, say male and female, and then you would constrain the paths to be equal, and you would be essentially looking for poor model fit. So what you're asking is, are the mediation paths significantly different from each other? Okay? So just conceptually, that's how these things work. And then here's just a figure of mediation at high and low. So just thinking about it in terms of mediation within groups is a good way to conceptualize that. So for those of you who have worked with moderated mediation, I did see a couple hands. What are the examples? You are volunteered.
Yeah, I'm doing one now, or I did one for my dissertation that I'm working on now, getting written up, and it's the X is duration of alcohol exposure, which I've operationalized as number of years regular drinking. My Y is brain white matter integrity.
Okay.
And then my mediator is how frequently the people have been drinking in the past 60 to 90 days, like on the timeline follow back.
Okay.
I'm just telling you about the one that ended up being significant. I tested lots of models. But this one was moderated by gender. So for women, there was a highly significant relationship, and it was at the B path. So frequency of drinking affected white matter negatively in women, but there was no effect in men. So the more frequently women were drinking, it was having a negative impact on the brain. But for men, that relationship didn't hold.
That's interesting. So are there thoughts on why that is, like their physiological reasons?
Yeah, there's been a lot of controversy in the literature about whether women have equal, lesser, more brain damage associated with alcohol use at similar levels as men, but just generally they are finding pretty good support for women having more vulnerability to neurotoxicity associated with alcohol.
Interesting. Okay. And you said you tested a lot of models.
Oh yeah.
Yeah. Yeah, and when you're probing these, I mean, I think that we can have feelings about multiple significance tests, but I will go on record to say that when looking at mediation, moderation, moderated mediation, often multiple tests are required. You really are probing the data to, one approach is to be probing the data to kind of tell the story of what's happening in the data. I think of this particularly in terms of clinical trials, and I haven't thought about it as much in terms of etiology, but in clinical trials you often have, you might have a significant treatment effect, you might not, but you know that in that whichever outcome you have averaged away a lot of important differences. And so mediation and moderated mediation are really a great way to kind of tell the story of the clinical trial. That's how I often think of it. And we base our questions on our theoretical understanding, but I feel like a detective, a data detective. That's what I call myself. What about other examples?
This example I shared before just looked at effects of discrimination on depression. So X is discrimination, Y is depression, depressive symptoms, and the mediator was self-esteem. And the moderator was looking at, the sample was black men, and within that there's certainly ethnicity differences. So I looked at Afro-Caribbean black men as well as African-American black men. And so the left moderator, the ethnicity.
And so you found that difference?
I did.
And so the indirect effect was in which group?
It held for African American men, but did not hold for African Caribbean men.
Interesting, yeah. And then for both of these examples, what methods did you use? Did you use like a Hayes macro, or did you use SEM? Did you use?
I used M+.
Okay. So you used SEM, basically? Yeah. Okay.
I tried SEM, but it didn't work, so then I did the macro.
Okay. All right, great. I think this is it for this. Okay, so this is from the Preacher, Rucker, and Hayes paper. So these are essentially the 5 different scenarios that you could work with. These are the conceptual models, and then when we go to the next page, I can show you the statistical models. But the first scenario is really when you have a situation of you're not sure if the mediator is a moderator or a mediator. So M is not a mediator of the XY relationship, rather X moderates M to Y. So the question that you would be asking in that circumstance is, is this variable best under this circumstance or that circumstance, which can arise often. Model 2 is W moderates X to M on the A path, okay? And that's actually the example that we're going to go over today. That's a continued example. We started, I think 2 weeks ago with a clinical trial of MI versus an SOMI, but then we moved on to a young adult trial of MI versus a relaxation training control, because it has stronger effects, and when you have stronger effects in a treatment trial, you do have an easier time looking at mediation and moderation. So we're continuing on with that. The next example would be W moderates M to Y, so that is moderation at the B path. So an example of this is a paper that I really like, where it's an MI versus I think pretty much like an assessment control. And the motivation changes in motivation post-treatment mediate the efficacy of MI versus control, but only for individuals at a certain level of motivation, baseline motivation. So it's the same measure, but measured, at 2 different time points. So one kind of thinking about their state going in affects how their process will change, right? So how motivated you are might drive how much motivation can act as a mechanism of your treatment effect. Does that make sense? Yeah? W moderates X to M and Z moderates M to Y. So you've got 2 different moderators, one at the A path, one at the B path. I have an example for this, which is some work that I did with a former postdoc from Cass, where we're looking. I do a lot of work coding MI tapes and testing the effects of therapist skills on a variable that's called change talk, client change talk, but it is client verbalization, saying, I will change, I won't change, I can change, I can't change. I did, I threw the beer out last week. It's like those kind of verbalizations that occur within a session. And so in this example, so with MI, there's the technical hypothesis, which essentially says that therapists that are skilled in MI-consistent behaviors that are demonstrating adherence to the approach will impact the mechanism, which is the change talk variable. And that the change talk variable will then predict outcomes, so that the change talk is a key process of change in MI, really as sort of an in-session marker of shifts in motivation, right? But in this case, this was a sample of young men, and they were pre-contemplative young men, so they all were kind of clustered in terms of their motivation level. It was a non-treatment seeking sample. So in this case, you needed really a skilled therapist, a highly skilled therapist whose experience was the moderator at the APAth. And you needed higher alcohol severity at the BPAth in order for change talk to act as a mechanism. So that was the effects that were found in this. You would think that motivation, so we have alcohol severity here, you might think, well, why not motivation acting as a moderator here? But like I said, it was a pretty pre-contemplative sample, so there was this restricted range in terms of how motivated they were. But the thing that we find with change talk is that people lie sometimes. And so this variable will have varying predictive validity depending on population-based factors. And it does take some pretty decent skills to really get high-quality change talk out of clients.
So remind me again, what was the Z? What was the moderator for the BPAth?
It was alcohol severity. So it was, I consider those kind of often two sides of the same coin, like motivation and alcohol severity. But in this case, like I said, motivation was restricted. So this was really just like they're a heavy drinking sample, but they had to be pretty extra heavy drinking in order for their change talk to affect their drinking outcomes.
So heavier?
So the heavier was where the indirect effect held. And probably, they had more consequences to talk about, more salience of the problem. So you think of those things as kind of affecting the validity of what they say in the session. Yeah.
Can I just ask like a more theoretical about this approach of using the macros versus like an SEM framework? So when you're exploring the data in this format, you're looking at the function, like the significance of the moderators individually when you're just trying to figure out the data? Or are you comparing model fit as well? I'm more familiar with SEM, so I'd be looking does the model fit the data better than the other model? But
no, you're not given those types of comparisons. So in terms of running different models. It's really path analysis. It's a series of regression models.
So you're just looking at specific paths and saying, all right, well, this is coming out of where signals coming out here, so like that's important. So that's the model that seems to make most sense of then interpreting that.
Yeah. And it's tricky because when in like a path model like that, then you can also think about the fact that there might be different people in this relationship than in this relationship, right? Other questions or thoughts? I mean, I think that I would be of the position that SEM is the preferred approach because you've got the potential for using latent variables. You've got the potential for modeling your measurement error and really incorporating the error structure into the analysis. And you're testing that single model simultaneously rather than a set of path models. That's my understanding. You're setting up one model, and then the maximum likelihood estimation is saying how likely is this model given this sample. So I would say it's better, but the issue is the downside is that you need decent size, you need decent skills, and you need decent sample size.
Do you prefer to do a latent moderator factor, or do you just constrain the sample based on like high or low or demographics? Like
Say it again.
Like in an SEM model, do you create a latent moderator variable or a moderator factor?
I would be more inclined just to test it the same way of doing an interaction term. Like, I use the example of constraining the paths to be equal between groups because it helps you conceptually think about what you're doing. But I would be more inclined to test one of these types of models within an SEM framework. Is that answering your question?
I think so. I guess I've seen some literature where they create a moderator factor in the model. They rather than constrain the sample like men, women, and compare the paths, they've actually created a moderator variable and tested to see if that's significant. I don't know. I was just wondering if you're familiar with that, or if there's a preferred method over another.
Yeah, I'm understanding it as the interaction term, so I don't know if I've seen some nodding, so I don't know if other people have more experience with this.
Yeah, so one way in SEM is you essentially do a multi-group model
Right.
and test whether the groupness is important. And the upside is it's more elegant and really does test the whole model from the interaction perspective. The downside is I've never had the experience of having such a model converge. So there's pragmatics involved as well. If you have 10,000 cases, maybe it works better, but
Right.
I had
But-
it work with a relatively small sample
Yeah.
size.
Okay.
Set up models.
no, it could just be the structure of the data that
Yeah.
we've been working with.
And to that point, so using this approach, you can get away with a smaller sample size than if you're in an SEM framework, you have to have, because every time you have a predictor, you have to boost the sample up. This one, you can get away with smaller sample.
Theoretically, this approach is also going to give you a list-wise deletion, which I guess SEM does as well. But you have to impute first.
You can specify the,
Yeah, you
the
can.
back, like,
Good full information.
yeah. That's
Yeah.
one of the benefits of using, like, because I've never had a data set where, like, you've got full, like, it just this never happens. And so that's why I've kind of leaned on SEM or hierarchical linear models where you can use different information criteria so that you can include everybody even if they haven't been values.
Yeah, and I don't know if it's directly a sample size issue, but indirectly, because this approach, your model has fewer parameters that are being estimated than if you do a group differences approach.
Right.
And even though you don't see it directly, when you're estimating more parameters, the association between the number of parameters and the number of cases, it just makes it harder to estimate parameters and achieve convergence when there are fewer cases.
But I mean, I have one of the people that I came from a program with a really strong quant piece to it, and so I had somebody on there that was also in the same kind of world where I am, and was like, you it's hard for you to get larger numbers, so you do what you can, kind of a thing,
Yeah.
and so to be the idea that you have to have millions of people to do SEM isn't necessarily the case.
Yeah. Yeah, and I think it's stability is key, right? So sample size can affect sort of the stability of your estimates, and so in that case you think about sensitivity analysis and kind of varying varying different paths or assumptions and seeing how stable your model is. Other questions or thoughts? And then, okay, so W moderates X to M and M to Y paths. So your name here, this is just waiting for you to fill in the blank. I think a good contender for this would be maybe a baseline motivation measure or something like that, where it could affect, how the treatment will affect the mechanism, but also affect how affect the predictive validity of the mechanism itself. So that's sort of my go-to example for that one. Any questions on these? So here's just looking at the models tested. In terms of discriminating them, you really just want to, you can focus in on the subscripts and to look at which model which model is being tested, right? So we've got the A3 and C3 here. So this is the moderation at the A path versus B3 here, moderation at the B path, versus Z and W. So this is where you've got the two separate moderators, right? Versus you've got the same moderator. Make sense? So when you get the, when you're working with the process macro in the documentation, that's what you're getting. You're getting this, and then you're getting the more sort of conceptual figure as well, which allows you to kind of really think through clearly exactly what you're doing. Just one thing to note though is that these model numbers are 1 through 5 based on the Preacher conditional and direct effects sort of typology. They don't map on to the model numbers that you would specify in process. Okay. So any questions? All right, so last week we talked about the effect of MI in contrast to relaxation, relaxation training control on week 6 drinking as being partially mediated by increases in motivation post-session, which reduce intentions to drink post-session and thus follow-up drinking, right? So we tested the sequential mediation model, right? So we've got the total effect here, which is that MI was efficacious over relaxation control on a variety of drinking outcomes among this young adult non-4-year college sample, right? So there was a pretty treatment naive sample. And then this is the sequential mediation model that we tested. But the thing that we talked about was that the model was essentially flawed in terms of temporality because we had these two concurrent mediators. So it wasn't, your motivation changes and then that changes your intentions and then that changes your behavior. We know in real life that these things don't occur separately, that they do in fact occur simultaneously. But then at the same time, we often do want some type of temporality to enhance our cause-effect conclusion. Does that make sense? I know I keep harping on the temporality thing. So maybe this model isn't so great, right? This is an example of kind of telling the story of the data. You've got strong effects here, but is this really the best story to tell? The right story to tell. So let's think of it a different way, right? Let's think of it in terms of moderation of the A path. So essentially we're asking whether the effect of the predictor on the mediator is conditional upon a contextual or population-based factor. Said another way is, does my treatment impact a specific process only under certain conditions or only for certain types of people? And so here's our process macro call, right? Our variable list, which is the Y, drinking, 6 weeks drinking, condition, MI versus rel. Baseline ladder, which is our moderator, and post-treatment intentions to drink, which is our mediator, baseline intentions to drink, which is just our covariate, and then baseline drinking is our other covariate. And so now we just plug in we just tell process where the variables need to go. Here's our mediator. Here's our moderator. And then anything that is left over, it'll automatically treat as a covariate. This is just how many bootstrap resamples we want, the coefficient tests, and then we're specifying model 7, okay? Which is moderation of the A path, which is this picture. So conditional indirect effect of X on Y through M, this is the sort of variation on the product of the coefficients, right? We've got A1 plus A3 times W times B1, right? Does that make sense? Go back. A1 times A1 plus A3 times B1, right? So 2 A paths, 1 B path. Here's our output. Here's our APATH model and just the summary statistics for the overall model. The main things that we'd be interested in here would be the significance and direction of the interaction term, right? And so what this tells us that drinking intention is highest when when you have low motivation in the relaxation control condition, right? Or vice versa. Drinking intentions are lowest when you are high motivation and you're in MI. Make sense? Here's just our interaction term defined, right? This is just to check the model. Here is our BPATH model. So this is where we're interested in the effect of drinking intentions on outcome, right? So we can see that post-session drinking intentions predict more drinking. Makes sense. What's that? Here's a figure. When I'm doing moderated mediation, I will always plot the moderation effect. You can plot the moderated mediated effect, but I don't find it the most intuitive visual plot. Whereas this is really allowing you to say, okay, this is what's going on at the A path, or this is what's going on at the B path that is then responsible for this process. So we have drinking drinks per week. No, sorry. This is your intention score, okay? And the REL condition and the MI condition, low baseline ladder, high baseline ladder. So drinking intention is highest when low motivation in REL. Drinking intention is highest when low motivation in REL, right? Said another way, the differential impact of MI versus relaxation control training on intentions to drink is only observed at low levels of motivation, right? That's what we're seeing here. Does that make sense? Okay, good. All right, so here's the direct effect model. Here is the conditional indirect effects of X and Y at different levels of the moderator. So usually when I look at these, I just kind of scan down the confidence interval and look for, where there's no zero. And so for these two, I sort of plugged in the numbers to illustrate the product of what the product of coefficients would be for the two significant values of the moderator, right? Which is low and medium. So we've got A1, which we go back, we go back as the effective condition, right? Then we've got A3 times W low. W low is right here, right? 1 standard deviation below the mean. So these two added together and then multiplied by B1. So wait, let's just 1.02, which is the coefficient for the interaction term, right here. And then the B path, right here. Make sense? Okay, so this is the default mean plus or minus 1 standard deviation from the mean. What does it tell us? It tells us a portion of MI's differential efficacy over the relaxation control is transmitted via its effect on reducing drinking intentions, which reduce subsequent drinking, right? However, the indirect effect is only observed when clients are at low to moderate motivation. So again, this makes sense because we can think, okay, well, there's probably some type of ceiling effect at high motivation in terms of the mechanism, right? So there's potentially a ceiling effect for drinking intention at high levels of motivation. Make sense? All right. So we could look at a different way. We could say, well, actually, I don't think it's really about how MI impacts the mechanism. It's about how the mechanism impacts the outcome. So then this would be an example where we're asking whether the effect of the mediator on the outcome is conditional on a contextual or population-based factor. The mechanism is only operative under certain conditions or for certain people. Here's our macro call, different model, number 14. This is what it looks like. Everything else is the same. Although it's V, it's new. Not sure why I made it red. Probably something I was supposed to tell you there, but I don't know what it is. The opportunities are endless, right? So we can, there's a lot of different ways to specify these models. So that's a cliffhanger. Actually stuck with the preceding model. So that's conditional indirect effects as examined via process in a nutshell. Any questions? Yeah.
So I was just, I have more of an SEM background too, so when you're doing these kinds of models and you've tested a couple and you found significant paths in both of them, how do you pick which model is the better model?
I think theory.
Okay.
Theory and maybe this the strength of the path, the strength and significance of the path coefficients. But really I think, it's theory and what is the more plausible explanation. Mm-hmm.
Can I see the slide again where you have the different SEM paths drawn out?
The 5 different models?
Yeah.
Sure.
Yeah, that was so the latent variables, those are the error terms, I'm assuming?
Yeah, but they're not being modeled. I'm not really sure why they're there, but.
Oh, okay, because I was wondering, it seems like they're conflated between certain terms but not others.
Yeah, these aren't, these are saying, okay, my understanding is that these are really, just illustrating the error is there.
Okay, but not necessarily for those variables in particular. It's just there's error.
Yeah, I'm not
Okay.
sure.
I was just curious.
Yeah, I've always kind of looked at those and gone, but I can tell you that they're not being tested,
Okay.
So therefore, why are they there? But there's, I'm sure, a very good reason.
And then when
Does
you
Ron
run
know
these-
the reason?
Well, in structural modeling speak, there's always an error term,
Right.
which is kind of implicit in regression modeling.
Right.
You're always addressing the error term by looking at the non-error part of the model. And model 4, model 5, what those are specifying are correlated errors, which you can specify in SEM. You could probably figure out a way to do it in regression models, but you'd have to seek out some people who do very exotic stuff and learn a whole bunch of stuff that's much easier to do in an SEM framework by 1 or 2 statements. And a lot of times, essentially what you're saying when you have correlated error terms is there's association between some of your predictors, and it's typically when you have a latent variable structure where you have predictors here and predictors here, and you're saying they're different factors, but we don't have any pure factors in what we look at, so there may be some association outside of the factor structure that in order to get the model to fit as well as you can, that you specify the correlated error terms.
But my understanding with these is it's just sort of saying, you should think about this, or this is something that's not being modeled, but that is of consideration and
Yeah.
importance.
Okay.
Yeah.
Other questions? That's really wrapping up process. So how do you guys feel about using it, or the idea of its possibilities in terms of those of you who like working in a regression framework? And again, I have no interest in I have no conflict of interest with process or Andrew Hayes. Okay, you guys are I'm getting the sense if you're still considering it, but not necessarily sold. Okay, so power for mediation. My understanding is they're not great options. I wrote this slide, whatever, 3 years ago or something like that, and I said, these things change all the time, so keep checking. And then every time, maybe more than 3 years, but I don't know if I've done this class once or twice. But I keep checking every time I say that, and actually the landscape doesn't necessarily change that much, or at all. So this macro for SAS, I did post this time, which I hadn't posted in the past. I haven't worked with it, so I don't know, how easy or difficult it is. I tend to work with the different power tables when writing up an analysis plan for a grant or thinking about power for analyses that I've run. And I find them very useful, and I've never had any pushback from reviewers in terms of that not being, sufficient. So there are power estimates for conditional indirect effects in this Preacher, Rucker, and Hayes paper, right? So if you want to talk power for moderated mediation, there is a table for that. The table that I'm actually going to talk about, though, is the McKinnon table, right? It's really easy to work with. It's, here's your Barron and Kenny. We're talking no effect, small effect, and this is indirect effect. This is coefficient at the A or the B path, right? So these are the interpretations of effect size, which would be small is 0.14, medium is 0.39, large is 0.59. So these are all Barron and Kenny. This is the joint significance in the Sobel test. So these are both the normal theory tests. Prodklin is the McKinnon asymmetric distribution product of coefficients test. And then these are two bootstrap methods. And you just go across and you're looking at the size of the effect at the A or the B path, and it gives you all the scenarios. Small, 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 high. No, wait, what's H?
Yeah, hi.
High? No, actually, because large. I don't know why it's H. Small. Well,
Yeah, it's
we've got a small, we've got a medium small, we've got a medium, and then we've got a large. Okay? And so then those are all the different combinations of A and B path effects. If you study the table, you can see how B path effects matter more in terms of power. But that can give you a sense of what your what the sample size you would need to detect that type of A and B path effects. Does that make sense? In terms of using it?
Which article is this?
This is the McKinnon et al. 2002, the required sample size to detect a mediated effect. It should be in there too on the course site.
Yeah, and the thing to remember about power is, unlike statistical models, you're not getting exact stuff because at the root of power is your effect size estimates, and if you knew the effect size, you wouldn't be doing the study you're computing power for. So you make reasonable assumptions, you grab from the table, and if you can, you say, you inflate it by a third or so, so that you have a safety margin, and that's why you don't get pushback, is people who understand power analysis well enough know that it's a good faith estimate when you're doing it in good faith.
Right. Right.
So,
And a range of scenarios is often
Yeah.
useful. You're going to provide a range of, based on theory, what would be the most expected magnitude of the A and the B path effects.
the other
Oh.
thing you can do for power of mediated and moderated tests within M+, there's a Monte Carlo routine where you can specify path coefficients in line with small, medium, large effects, however you want to do it. It's numerical, so you can do it, and then it runs through these scenarios and do something while it's grinding through all of the iterations. You want to set it to like a 500 or 1,000 iterations of sampling and estimating the power, and the upside is you specify the whole model. The downside is you don't get a power estimate for the whole model, you get a power estimate for individual parameters, but typically in a mediation or moderation model, there's really one parameter, which is going to be the hardest to detect. So you can also do it that way.
Yeah, and that sounds like the ideal way to do it.
Mm,
No?
No,
I mean,
actually,
it
you get
sounds
some
more
pushback
more
on it
spec-
because of the fact that you're only estimating one parameter at a time.
Uh-huh, okay. Other questions or thoughts on power? All right, I just have 2 slides left about extensions. I'm not going to do a good job on this because I'm now going to talk about causal modeling. But I've spent a lot of time sitting in conferences, workshops, lectures on causal modeling. And I've done it because I feel like I should know what's out there, and I should know, because the causal modeling folks have a lot to say about how we're, how, like, say, regression-based or SEM-based approaches are doing it wrong. So knowing that other position that's out there and that is sort of gaining steam, I will admit though that I find it very difficult to understand. So who's familiar, sort of dabbled in the causal inference literature for testing mediation? So the Tyler Vanderweel, Judea Pearl, all of those people. Well, at the Center for Statistical Sciences, they're actually hugely into it, so they have lectures on it all the time at the in the CAS building on their Monday statistical series. So I've gotten a lot of good talks there, and then they did the anyway. Okay, so I'm going to try and explain the basics. A true cause-effect relationship is derived when you can determine the outcome y under condition 1 and condition 2 for each case, right? You know the outcome under all feasible conditions. Because this is impossible to do, we randomize to experiment and control. And the reason that we do that is because we want to equalize the cases across group, therefore rule out alternative explanations, therefore strengthen the inference for the causal effect. The problem is that we can't randomize M to Y, right? We can't randomize M. We can randomize X to M, but we can't randomize M to Y, generally. So folks have talked about alternative methods for enhancing causal inference in mediation tests, and this is the causal inference literature. So, how does it work? It includes the incorporation of estimates for counterfactual circumstances, so you essentially estimate mediator effects for those assigned, those who would be hypothetically or theoretically assigned to all different levels of the mediator. Typically, these estimates are derived from the use of what they call instrumental variables or encoded predictors that allow for outcome estimates under counterfactual circumstances. These methods require a lot of assumptions, cases, although I'm not saying, you have to have a huge sample to do this. And when M is continuous, your range of counterfactual circumstances can get quite unruly, right? That's really all I'm going to say about it. I think what I would say also, though, in terms of the issue of not randomizing M, is that the experiment criteria for M is clearly important, but we can also think, I kind of go back to the cast and knock incremental criteria, and I think about, basic research, the lab studying the mechanism in the beginning, right? And then the mechanism gets incorporated into the clinical outcome research, and that ultimately, and it gets some support, and that ultimately in the end, you probably would go back to the lab and try and do some randomization to the mediator in relation to the outcome as the kind of final step in validation of that mechanism. That would be, or you do causal inference stuff if you're very smart and understand complicated things. Other extensions would be SEM, particularly because you can incorporate latent variables and measurement error. It used to be that categorical mediators were a problem. It no longer is, so that's another advancement. You can calculate the product of the A/B path coefficients within a longitudinal framework, so with GE or MLM. I think conceptually, I always ask myself whether I would want to, because it seems kind of strange to think about an average over time as a mechanism. You would I think of a slope over time as a mechanism, right? Some type of growth process as a mechanism. So latent growth curve models might be a better way of doing that, because then you are going to be able to get intercepts and slopes for a mediator, so you're able to model a growth process for mediation rather than just an average of a mediator over time, right? So for someone like me with the change talk, change talk is supposed to grow in the session, right? Motivational interviewing is supposed to increase motivation throughout the course of a session. And so the ideal test of that mediator is the test of a slope, not the test of an intercept. Make sense? And here's a paper or two.